Hello, in this lesson we are going to be taking a look at magic numbers and how we can counter them by using blueprint variables. So in the previous lesson we added the ability to roll the player pawn around the level based on the player's input, and we do this by adding torque to our mesh component. Now we've had to use an incredibly large number to get the result we want in our multiplier here. And this is because the torque is taking the mass of our mesh into account, and the units are in Newton centimeters. But we're not really fussed about the mass of our sphere, and we're just tweaking this number here to get the result we want. Now notice there's two other inputs on the torque function we haven't looked at yet. There's bone name just here, and we can ignore this because this only applies to skeletal mesh components, and we're using a static mesh component. At the bottom, we have a Boolean input for acceleration change. When we hover over this, it says, if true, torque is taken as a change in angular acceleration instead of a physical torque. In brackets, it says, i.e. mass will have no effect. So this is saying that if we set this to true, it's going to completely ignore the mass of our sphere, and we will no longer need to use such a large multiplier value, as it will immediately start applying the angular acceleration without the mass taken into account. So let's try this. Let's check the acceleration change. Let's set it to true. And this multiplier value here, let's change this to something like 12. Let's do the same below. We can check acceleration change for our move right and move left axis event, and we can change the multiplier value to 12. And now if we come into the level and hit play, notice how we still have complete control over our pawn, but without having to use such a large value for the force. Now let's come back to our blueprint. Okay, so at the end of the last lesson, I said that this number that we're using for our multiplier is known as a magic number. In programming, a magic number is a number that appears in our code without any meaning or explanation. When we view our code in blueprints, it's not immediately clear to us what this number 12 does. Okay, and magic numbers used in multiple locations can lead to issues in our code. And we have used a magic number multiple times in our code. Imagine that we want to make a change to this number and we only change it in one location, forgetting about the other location where it's used. It's an easy mistake to make that we would want to avoid. Magic numbers make it harder to change our code. So we want to avoid magic numbers, and we want to avoid them because the intention of a magic number is not clear. And magic numbers make it harder to make changes in our code. Okay, so what can we do instead? Well, we can make use of blueprint variables. Blueprint variables can be assigned a value or a reference. And the variables can be clearly named, improving the readability of our code. And best of all, blueprint variables can be reused multiple times in different locations. If we change the value of the variable, it will change it everywhere we have used it. So we only have to change the value in one place. So how do we go about creating a blueprint variable? Well, first we need to restore the My Blueprint tab to the editor's interface, and we can do this by selecting Window, and then we can select My Blueprint. Now with the tab restored, we can find a section for variables, and on the variable section on the end we can hit this button to create a new variable. And when we do this, it adds a variable in and it asks us to name it. I'm just going to name mine My Variable. Now there's different types of variables, and we can change the type that we're using by selecting the color next to it. This is indicating the type of variable it is. It says the current type is a Boolean. If we select here, we can change it and switch it to a different variable type. And we can hover over these. We can see the name of them already, but if we hover over these, it says exactly what they are. And you can even hold Control and Alt to give you some more details about the type of data. Now everything, as we can see, is color-coded in blueprints. We've been working with floats here. We know it's a float because it's green, and if we hover over the pin, it tells us that it's a float. So if I change my variable to a float, I can do it here, or I can do it on the details panel. With the variable selected, I can drop down Boolean and change it to float. Now looking to the bottom of the details panel, we can assign a value to it. It says default value, but it says please compile the blueprint. So we just need to hit compile, and now we can assign a value to it. We can click and drag it and use it like a slider, or we can simply type in the value. Okay, we can put in any number there, and to actually get a reference to the variable, or to get the variable and use the value in our blueprint, we can drag it out and release it, and we can hit get, and then this gets the variable. And look, it's very similar to how we've been using the blueprint references here. It adds a node in and it has a pin, and we can click and drag it to do something with it. We can release it and call a blueprint action, or we can click and drag it and plug it into something. So now it's your turn. In this challenge, I want you to create a variable. This variable is going to replace our magic number. So I want you to give the variable an appropriate name. What does the magic number do? So name it something like acceleration multiplier or torque strength, but I'll leave it up to you to come up with the name. And make sure to change the variable to the correct type. And then get the variable and plug it in to where your magic numbers are. And then the final step, make sure to assign a value to it. So pause the video here, then when you've completed the challenge, come back and resume the lesson. Okay, so I hope you've had a good go at the challenge. I'm going to remove my variable that I've created and delete it from the variables tab just by selecting it and hitting delete. Right, so I had the value of 12 in here. I'm going to type that back in. So I want to create a variable to replace this magic number that we are using on both of our multipliers here. So I'm going to hit new variable, and then I'm just going to name it acceleration multiplier. And then hit enter to confirm it. And I'm going to hit compile straight away so I can give it a value. I'm going to give it the value of 12. Now we can use this to replace our magic number. We can click and drag it out and get it and plug it straight in. And we can do this again. We can click and drag it out and get it and plug it straight in. Okay, so that's how we can create variables. But I'm going to delete it again. And I'm going to show you one more way that we can do this. If I put the value of 12 in here, we can actually right click on this input pin and we can select promote to variable. And when we do this, it automatically creates the variable for us as a float. I can just name it again. I'm just going to name it acceleration multiplier. And if you do this, just make sure that we have the variable plugged in to where we multiply our move right and left axis value. And just confirm that you are using it for moving forwards and backwards as well. Now, because we promoted it to a variable from the magic number, it's already assigned the default value for us that we were using. Okay, great. So now you know how to create variables in Blueprints. We can hit compile and save and then come back to our level and play our game. We can see that we can move around just like before. But now if you want to change the angular acceleration, you can just change the default value of your variable. Okay, so that's it for this lesson. In the next lesson, we are going to be taking a look at the BSP Extrude tool. Hello and welcome to this lesson, which is all about using the BSP Extrude tool. So we can move around with the player pawn, but we can only move so far because we have these gaps in our floors. So what we're going to do in this lesson is create some bridges that the player has to navigate across in order to proceed throughout the level. And we're going to continue making use of the BSP brushes to make this happen. So to get started, I first want to make a slightly larger gap between my floors here. To do this, I'm going to go into the geometry editing mode and select this side face of my floor here, and we can just drag it to make a larger gap. Now I'm ready to start laying down this bridge of sorts. I'm going to come back into the modes panel, and in the modes panel we can come into the geometry section and we can drag out a new box brush. I want it to be around the same thickness as the floor. We can select the floor and scroll down on the details panel and we can see that it is 20 on the Z there. So I'm going to use that same value of 20, and on the Y here I'm going to change this to 100. Okay, and I'm just going to place this inside the floor here, and we can choose anywhere along here as the starting point of our bridge. So we know we can come into the geometry editing mode, and in the edit mode that's automatically highlighted, we can select faces and drag them to change the length of the brush we're dealing with. But we haven't taken a look at this extrude mode. When in extrude mode, you can create new geometry from existing geometry. How do we do this? Well, we do this by dragging a face. By dragging a face in extrude mode, you create new faces. Extruding allows us to create more complex shapes out of our BSP brushes. So let's look at extruding this face just here. First, we want to make sure we have the face selected, and then on the geometry editing tab, we can select extrude. Now, when we do this, it tells us that extrude only works with the local coordinate system. We're currently in the world coordinate system mode. This is what this icon means here. As soon as we hit close, we can see that it changes it to local for us, and we can toggle between that just by clicking there, but we need it on local when we are using the extrude mode. So with extrude selected, when we drag this face, we are creating new faces. Let's take a look. If I click and drag it now, we can see we've created some new faces here. These are all new faces, and we can select any one of these faces, and we can also extrude these. We can switch back to edit mode, and with the face still selected, we can actually change the height of it, so we can start to see how using the edit and extrude together, that we can start to create some more unique designs across this gap here. So right now I have a challenge for you. Using BSP brushes, create pathways across gaps in your level that the player has to navigate. Make good use of the extrude and edit tools to do this. And remember, you can adjust the height of faces in edit mode. And play your level to make sure the player pawn can navigate your pathways. This might take some time to get right. It's down to you to design it. So don't be afraid to start over with it. Try to come up with some interesting pathways that work. So pause here, and once you're ready, come back to the lesson and hit resume. So using the geometry editing tools with the edit and extrude, I have created my pathways. My first pathway has a little spot for a crystal pickup on it, and my second one, I've opted for a under and over design here. Now all I need to do is apply some materials to them. We can select the brush, and we can drop down select on the geometry section on the details panel, and we can select all adjacent surfaces, and we can drag and drop a material onto it. And I'm just going to repeat this to apply the material to my first pathway. And while designing these pathways, I made sure to keep hitting play and playing the game myself to make sure that the player pawn can actually navigate across the pathways. But also while playing, I came across an issue with the camera on my second pathway. Let's take a look at what happens. You can choose where to play in your level easily by right-clicking and selecting play from here. So this is incredibly handy when designing levels. So when I play from here, when I move across my pathway and when I go under, notice the camera kind of looks like it's freaking out when I go under it. And this is happening because the spring arm component of our player pawn is colliding. By default, the spring arm component detects collisions, and it auto adjusts the length of the spring arm to where the collision occurs. So we want to disable this behavior. So I want you to open up your player pawn blueprint and select your spring arm component, then disable do collision test. Okay, so to fix this, we need to come inside the player pawn blueprint. We can select the spring arm components from the components list, and then on the details panel, we can simply uncheck do collision test. Okay, we can hit compile and save, and we can close the blueprint. And now if I was to right click and hit play from here and navigate through my pathway, we can see that the spring arm no longer auto adjusts for us. Okay, great, so we have these pathway bridges that we can use to navigate across the map, but of course we can actually fall off them. So in the next lesson, we're going to handle restarting the level when the player falls off.